Welcome to Study Loop.
So in this question, we have radio stations that has two antennas emitting signal at the same frequency. And we're asked to measure the maximum and minimum signal when we are very far away from the radio station. So this is actually equivalent to a double slit interference problem because you can think of it as these two antennas, they are two sources of signal. So it's not too different from having light from the two slit in a double slit interference question. So this D, this 9-meter distance, is the same as the D we have for double slit interference. So this question really is asking that if we have a double slit interference and we have this D, and then when we measure the signal over there, what is the angle that gives us the maximum and the minimum? So first, let's try to convert the number into our familiar ones because we are given the frequency of the radio wave, but usually the parameter that we are more familiar with is the wavelength. So let's first convert frequency to wavelength. We have lambda equals v over f. But v here, it's radio wave, electromagnetic wave, so it's the speed of light. Frequency 90.3 times 10 to the 6 hertz. This gives us a wavelength of 3.322 meter. Now we can go back to our familiar double slit interference equation, d sine theta equals m lambda for constructive ones and d sine theta equals m plus 1/2 lambda for destructive ones. So this is the maximum signal and this is for the minimum signal. From this we get theta equals arc sine of m lambda over d. Theta equals arc sine of m plus 1/2 lambda over d. Okay, so this is the equation we have. Let's now try out what the question asks us. What are other angles that theta is a maximum can be detected in a minimum? It does not tell us how many of these values we want to find, but we know that because sine theta is at most 1, that means this number m lambda over d, we can only find the number of m's, so that this value is smaller than 1. If eventually m gets so large that this value exceeds 1, there will be no solutions. So there are a limited number of solutions we can find. So let's first say m equals 0, of course. So, let's start with non-zero because if m equals 0, then that's just a middle maximum, and we already know that. For m equals 1, we have theta equals sine negative 1 of lambda over d. That is, if I plug in the numbers, lambda is 3.22 meter over 9 meter. So that gives us 21.7 degree. That's the place of the first maximum. I call it theta 1. And theta 2 is for m equals 2. I have 2 lambda over d equals negative 1, 2 times 3.22 meter over 9 meter. So that gives us, if we plug it into the calculator, 47.6 degree. So that is the position of the second maximum. Let's find the third one. Theta 3 equals arc sine of 3 lambda over d equals 1 times 3 times 3.22 over 9 meter. But 3 times 3.22 is larger than 9 because 3 times 3 is 9. It's larger than 3. So this value exceeds 1. So when we do arc sine, we will not get any solution. So this is impossible. So we will only observe two maximum, one at 21.7 degree and one at 47.6 degree. this is a maximum. Okay, let's go on to work at the minimum. For the minimum, we now can consider m equals 0. So, because we always start m from 0, we didn't do that for maximum just because we already know there will be a maximum at the central line. So m equals 0, that would give us theta equals 0, which does not provide too much information. But for the minimum when equals 0, we have theta 0 equals 1 1/2 lambda over d, and that is 3.22 meter, 2 times 9 meter. And it gives us 10.6 degree. That is the 0th order minimum. And let's go find m equals 1. M equals 1, theta 1 equals 2/3 lambda over d. And that gives us over 2 times 9 meter, 3 times 3.22 meter. And that is equal to 34.4 degree. Okay, so what about m equals 2? And theta 2 equals -1. Now we have 5 lambda over 2d. So again, we're plugging all the numbers. And this gives us 70.3 degree. At last, we have m equals 3. And theta 3 equals sine -1 of 7 lambda over 2d. And we can plug in the number to try it out, but we can also observe that here, when we have arcsine of 3 lambda over d, 3 lambda over d is already larger than 1. So now we have 7 lambda over 2d, which is 3.5 lambda over d. So it will be even larger than 3 lambda over d. So we can be sure that this one will not have any solution. And so is the case for any larger m's. So for the minimum, we have 3 possible solutions. We have 3 angles that we can observe the minimum. So yes, so that is what is asked from the question. So the question asks us what other angles theta is a maximum signal detector, 21.7 degree and 47.6 degree. And minimum signal, then that's 10.6, 34.4, and 70.3. We have 3 angles at each side where we can detect the minimum signal.